So just a quick introduction about myself. My name is Derek Parker. Um, I created the Delve debugger for Go. I've been working uh, with Go and on Go related things for several years now. And so what I'm kind of really passionate about is like the tooling around Go, specifically debugging and that kind of thing. So um, the talks that I usually give are mostly around debugging, and this one's no exception. So let me share my screen real quick. Okay, so can everybody see my screen share? And is the font reasonable? Can everybody kind of read what's going on?
Yeah.
Okay, perfect. So just to kind of intro this talk a little bit. So this is kind of a talk that's a slice out of a longer workshop. So the flow of this talk is going to be very like interactive. So you won't see any slides. In fact, this is the closest that we'll actually get to a slide is just this README. So I'll kind of go through the README, explain how the talk is going to go and the outline of it, and then we'll get right into the bulk of it. So the title of this talk or workshop is called Bugs on a Cluster. So what we have here is there's a repo that I've created that contains some initial code, and then during the course of this talk, we're kind of going to be building up the repository and adding to it with new code and some makefile commands and things like that. And then I'll be pushing my changes to this repo and this branch so that everybody else can kind of follow along. So if you want to start getting going, if you can see it highlighted, and I can post this in the chat if that's easier, but if you use this git clone command, that'll clone down the repository and put you on the right branch. So essentially, as I go through this talk, I'm going to be putting code into this repo, committing it and pushing it. And as I go, you're encouraged to go along by pulling down the changes and kind of running things as I run them. And hopefully there won't be any issues on anybody's machine or anything like that. If there is, maybe we can try to solve them as we go along, or kind of meet up with me afterwards and we can try to figure out where things went wrong. So some prerequisites that you should have before getting started. Since this is a Go meetup, I assume everybody has a Go toolchain on their laptop. It is also encouraged for you to have Docker or Podman, something that has a Docker compatible like command line interface. And that's for, obviously, we're going to do a lot of like container kind of stuff. So we need some sort of container runtime. And also it's ideal if you have kubectl and kind on your system as well. That as we go through, I'll kind of put in some like some stuff in the makefile that you can pull down to install some of these dependencies if you don't already have them. But it's just some prerequisites to kind of get going so that everybody can follow along. But that should be all you need to be able to go through the workshop along with me. So essentially what we're going to be doing is kind of like, we're going to start with a small little application, and then we're going to go through how to debug it in different scenarios, right? So we're going to start with how to debug on the host, how to debug within a cluster, and then from there, or I'm sorry, how to debug within a container, and then from there, how to debug within a cluster. So progressively, things are going to be getting a little bit more difficult, and we're going to have to solve some kind of different and interesting challenges as we go. Now, this talk is mostly focused on how to get the debugger into the environment that you want to debug on, and how to set it up so that you can have a positive debugging experience. So we won't be going through too much of the ins and outs of Delve itself, and like the different commands and stuff like that. I'll leave that for a different presentation. So we do assume a little bit of familiarity with Delve, but nothing too extreme. And as you follow along, you'll be able to see what I mean. But essentially, we're trying to figure out through this talk and through this workshop how to get Delve where it needs to be and set up correctly so that you can debug in different environments that might not just be directly on your local machine. So we'll start off by just looking really briefly at what it looks like to debug on the host and how easy that is compared to everything else. So we'll learn how to start up Delve so that it compiles and runs your program. And then we'll learn how to compile your program so that it's best to run under Delve if you don't have Delve compile your program for you. Moving on from that, we'll start looking into how to debug within a container. So we'll work through how to set up your host system and your container to be able to debug properly. We'll learn how to copy the debugger into a container and debug within that environment, like execing within a container. And then we'll also learn how to do some remote debugging from a container environment. And then we'll follow kind of the same path with the Kubernetes cluster as well. So debugging within a cluster. So we'll learn how to kind of set up our pods and like deployments and things like that to be able to run a debugger. We'll learn how to copy the debugging tools into the pod containers. And then we'll learn how to do some remote debugging into containers running on a Kubernetes cluster. And then we'll also learn a little bit about how to use some kubectl commands to make all of this a little bit easier. So the flow is kind of like when we get to container and cluster, it's kind of like start with what's the hardest and then kind of get progressively to what you probably should be doing. So with that, we'll dig right into the kind of step-by-step of the code. So the first thing that we need to do if we're going to start debugging something is to actually have some code to debug. So I'm going to go ahead and copy a new file into our workspace here. So if you look at this new file, it's really basic. We just have a main function. It just prints out, the port that the server is going to be listening at. It sets up an HTTP handler and then starts an HTTP server. And then our handler is just this simple piece of code down here, this little function, which essentially just kind of echoes out the path that you are requesting. So pretty simple, nothing too like crazy or surprising here. Now, one thing that I kind of like to do with this is, as I said, I'm going to be kind of committing and pushing stuff as we go. So as part of this, I'm going to be building up a make file with commands so that the commands that I run are put down somewhere so that you can kind of take a look at them afterwards or while something else is happening. So let me go ahead and just commit this real quick. Push that up. So now everybody should be able to pull that down. And we're going to go ahead and create a new file here. So let's create our make file. So now we have an empty make file, not doing anything too useful. So let's start populating that and kind of go through the course. So one of the first things that we want to be able to do is just run the app. So let's start filling this out here. So I like to kind of separate things a little bit for my own sanity and for everybody else as we kind of go through and add tons of stuff to this make file. So we're adding this little make file command here that simply just runs the HTTP server, or runs our little Go program, right? So let's make sure it works. Here we have a terminal that's already in the directory we want to be at. So we run and it's successful, right? We see that the server is listening here. Let's prove that to ourselves a little bit more. So let's create another little makefile command where we can ping our app a little bit. So we have this other makefile command that just executes a curl command to our server, and we'll see what the response is. So in this other terminal, we can run make curl app, and we see, we actually get some stuff back. Our server's up and running. So nothing too crazy there. So let me go ahead and add run and curl. Okay. So now those should be available for anybody to kind of follow along with. And now that we've seen our app running and stuff like that, what we really want to do is debug it. Now, typically kind of what I like to do is create like a scenario around like we have a bug that we'll kind of solve and kind of go through, but there's so much information to be packed into such a relatively short time that we're going to keep it simple and just kind of go through the motions without kind of having like an underlying narrative. So now that we have the we can see the server running and everything like that, let's start looking at how to debug it. So the first thing that we're going to want to do is install Delve. So if you don't already have Delve, here's a quick little makefile command to be able to install it. So it basically just does a quick go install. Now, assuming you already have Delve on your system, let's first look at how easy it is just to debug a Go program on your host, right? So when you're already within the directory that has like the main package or whatever, it's literally just as simple as typing delve debug. And even though this is like a really simple command, like I said, the goal is to kind of build up this makefile with different commands so that everybody can follow along. And if you ever forget anything, even if it's a simple command, you can always go back and take a look at what we've done. So let's add this command, and then let's take a look at what it actually does, right? And poke around with the debugger a little bit to familiarize ourselves. So here at the terminal, we can just type make debug. And if you're not super familiar with Delve or how it works by default, I'll kind of dig into that a little bit right now. So essentially with just that command, what Delve has done is it has compiled your program for you, and it compiles it by default in such a way that like optimizations and things like that are disabled. So if you're unfamiliar, Go will by default enable optimizations. It's not like GCC or LLVM or anything like that, where by default you're getting like totally unoptimized code and you have to dash 04 03 or whatever to start getting optimizations. The Go compiler will do that automatically, and sometimes these optimizations can make debugging difficult. And this includes things like inlining of functions and things like that can make things a little bit difficult. Definitely not impossible. And the support on both sides from the Go compiler and from the debugger of debugging these optimized programs is increasing. But to get the best experience, Delve can handle compiling your program for you with the correct set of flags to make it your debugging experience as fruitful as possible. So now essentially we've started up this debug session. We've compiled the program. Delve has started it for you and attached to it already. So we're attached to the very first kind of bit of execution of our little cloud native web server that we've written. So we can see like we're stopped at the very, very beginning of execution. We really don't have any source available. So let's start continuing and get to something useful. Well, actually, first, let's set a breakpoint and then try to trigger that through the curl command. So we can search for our functions here. So I believe, yeah. So I remember the function was named hello server, so we can search for it that way. So let's set a breakpoint on main.hello server, and then let's continue executing. So we see that our server is actually starting up now, and it's just waiting for something to do. So let's do our little curl command again, and we can see we hit the breakpoint, and we see the source code being output. Everything looks nice and normal and exactly how you would expect it to. You can kind of like mess around a little bit. You can see different commands, right, to see local variables and function arguments and things like that. So now we have a little local command we started kind of poking around with, really easy to get set up. So as I mentioned, one other quick thing for debugging on the host. So I kind of mentioned that Delve will compile your program for you in a specific way. So what happens, like if you are trying to debug a larger program where maybe it's not so easy just to do like a Delve debug with the main package, like maybe you have like a really complex makefile or something like that, and the only way to debug your application is to start debugging a pre-created binary. The best way to be able to do that is to try to mimic the set of flags that Delve uses when it builds your program. So at a very minimum, what you're going to want to pass along is these GC flags, all, and then -n-l. So essentially what that does is that turns off a lot of the optimizations that are on by default to make your debugging experience a little bit better. And it's one of the main flags that Delve will pass along when it's compiling your program for you. So now that I've added this, let's do add build make command, push that up. Okay, so now we can just execute make build, and we see that it put our application here in bin app. And I don't have a little makefile thing for this because this is just something that I wanted to show. But if you have a binary already on disk that's produced by a makefile or some other build system, you can't run Delve debug directly. Another way to run Delve locally is exec, and then you provide it the path to a binary, right? So we have bin app, and it's the same thing, right? So we're executing a binary that's already created instead of letting Delve build it for us. And then we can do the same thing, continue, and we can, make requests. We see that it's actually running. If you want to stop the debugger at any point, you can just Control-C it, and it'll stop and kind of show you where it stopped when it got that signal, and then you can exit from there. So that gives you an idea of how to do some local debugging and how easy and simple it is. So from here, let's extrapolate that out and see what it looks like to debug in a Docker container. So first of all, let's copy over a few things to our makefile and to our new repo here. So let's go back to our makefile and start adding in some container related commands. So these are going to be, this is going to be the section for the makefile commands that we use for interacting with containers. And now I've just kind of set up a few basic like makefile variables here, and I've included one command which is just to build an image, right? So we want to do a Docker build of this Docker file here, and we're tagging it, basic image. And so we need to get that file over. So let's create that directory called build, and let's get our Docker file over there. So here's a Docker file that we're working with. It's a little bit contrived, but I'll talk through it and why some of the decisions have been made. So we have a builder. So this is a multi-stage image build. So we have our builder image, which is just Golang 117, a little bit outdated now that Go 118 just came out today, but what can you do? So we have our working directory, which is going to be project. We're copying everything from basically the host, like the root of this repo, into our working directory. And then we are running go build. So we're compiling our app. And then from an Ubuntu container, we're copying our built binary from the builder image. And then we have a little command entry point that just runs the app. So nothing too crazy or involved here. So let's go ahead and run that real quick. So we're going to just build our image here locally. Push those changes up for anybody who's following along. Okay, so now we have a container image that has our app that's already compiled and it's ready to go. So now how do we kind of get in there and start debugging it the same way that we were just doing on the host, right? Because, you know, when you run a container, the reason why containers are so powerful and important are not only just as a distribution mechanism, but also as a way of isolation, right? So you have different namespaces and things like that. So PID namespaces, mount namespaces, things like that, that prevent you from seeing kind of inside the container and prevent the container from seeing outside. So from you as the host and your debugging tools are on the host, clearly you can see we didn't build any debugging tools or anything like that into the image the container image that we just built. How do we get in there and start debugging? So let's talk about how to run this Docker image so that we can start copying our stuff in there and start debugging, right? So we already have our little makefile command to build the image. Now let's add a little makefile command to run the image. So we're doing a pretty basic Docker run. So Docker run, keep it, have a TTY and all that stuff. Detach so that it kind of gets backgrounded. Expose a port and then remove when we're done. So let's run that. And commit this. Okay, so now we have our container running, and we can verify with some of the commands that we already have that it's running and we can reach it, right? Because we did that port forwarding. So we should be able to just execute this curl again, and we see the container is running, the server is running, and we're able to hit it with our curl request. So now let's start seeing how we can kind of get in there and start debugging the server now that it's running within the container. So the first thing that we want to do, since as noted when we constructed the container, we don't have our debug tool in there. We don't have delve in there. So the first thing that we're going to want to do is copy our debugger into the container. So what that really means is we're copying it into the mount namespace and things like that, so that we can eventually execute exec into that those namespaces and run our debugger. So let's grab another makefile command here, which will take care of copying the delve into the container for us. So it's pretty simple here. Essentially, we're just executing Docker CP command, finding the path to the delve binary, and doing some kind of Docker kind of gnarly search nonsense to find the container image ID that we want to copy it into. So let's add this. Okay, so we've synced those changes. Now let's give it a try. Let's run it and see what happens. So we run make copy delve to container. So the command outputs, we've copied it in. So now we have our debugger within the container namespace, but we still have no way of kind of getting in there to executing it. So how do we exec into the container namespaces, get into that isolation area, and start being able to run the program and everything that we've copied. So to do this, we're going to want to exec into the container. So to be able to do that, we have this other, our new makefile command, just exec delve basic container. And here we're doing a basic Docker exec into the container, and we're providing a command. So we're saying just automatically execute this command, which is delve attach one. And if you remember, we copied delve to just the root of the container file system. So our command is just execute delve at the root and attach one. And if you remember from looking through the Docker file, the main entry point of our container is just to execute the app, the little server that we built. So that's going to be PID1 within the container. So we already know, we just want to go ahead and attach to that. So now with delve copied into the container and our exec command set up, we should be able to get a delve prompt. So let's try it and see what happens. And there we go. So we have a container. We're able to exec into it, and we're able to kind of attach to the container. Now there is usually this results in a bit of an error, but I might not have reset my system real quick. So let me. Try that again, actually. Okay, so I was running through this demo earlier, so I didn't reset my system correctly. So what should have happened is actually we get this error. So I wanted to show this error specifically because this happens a lot, and it's something that a lot of people run into. So I wanted to touch on it. Essentially, when you exec into the container, a lot of Linux systems have this Yama ptrace scope setting, and a lot of times it's set to be a lot more conservative. So what this does is it kind of limits how debuggers can work. So underneath the hood, debuggers use on Linux and Unix systems for the most part, they use a syscall called ptrace, which handles a lot of the heavy lifting for what a debugger actually needs to do at a very low level. So the host system can have different security settings around which process and which user is allowed to ptrace another process. So with this, we get this error, right? So there's two ways actually to fix this. The first way to fix it, we'll actually have to stop the container and rerun it. So let's take a look at what that looks like. So here's just our little command to stop the container. And we want to rerun it, but we want to rerun it in a slightly different way, which is gonna be one of the workarounds around this issue that we just saw. So let's see. Let's put this up here. So we have another Docker run command, but this one's a little bit different. So if you see, for the most part, it looks exactly the same, but we have one addition here. So when we run the container, we're adding a Linux capability for sysptrace. So by default, like Docker containers will have a pretty limited subset of Linux capabilities, which, if you're unfamiliar, is like a Linux security mechanism. So if we add sysptrace, any process that's run under that container process tree will have that capability added to it. So with this, we should be able to get around once we copy our debugger back in and execute it, we should be able to get around that Yama ptrace scope setting without having to make any changes on the host. So let's go ahead. Sync that and run it. So we're going to make run basic image, and this time with the ptrace capability. So similar thing, if we curl, we see our app is running. And again, we've resetted our container image. So we want to copy our tools back into it again. So let's run copy delve back to the container. And now let's exec into it again. And you can see where we just had that error message, you can see that now we have a fully functioning prompt at the command line. And so this is kind of one way to set up your containers to actually be able to run the debugger within it. And so that's kind of what I alluded to at the beginning of the talk when I was talking about like setting up your containers and things like that to be able to run these debugging tools and all of that in the first place. Now, this is kind of like a local solution, right? So this will allow you to run debugger in a container that you've copied in, as long as it's under that same process tree. So there's another way to do it, which is to let's stop our container again. So another way to do it on a more global level, if you don't want to add sysptrace capability to your each individual container, and this trick is kind of cool for a different reason as well. So I'll kind of show it. So first, let's go back to running our basic image. So this is running it again as we ran it the first time without the ptrace capability added. So run the basic image. Let's copy delve to it once again, and then let's try to do our exec. So we see we get that same error. So what if we wanted to work around this error without having to stop the container and rerun it with a different scope? Like what if it's already kind of where you want it to be to start debugging? The way to get around this is to change. You can actually change the ptrace Yama settings at a host level, and then kind of get around this issue. So here we see we're essentially putting 0 into this file in the proc file system, and basically what this is saying is set ptrace scope to 0. So it's 0, 1, and 2. Which with each being more restrictive. So 0 is pretty much wide open. So you might not want to do this on your host. If this is your personal machine, maybe not so bad, but like on a server or something like that, you might want it to stay more restrictive. So in those scenarios, you might want to actually still kind of fall back to the capadd sysptrace. But let's just see what this does, right? So we'll go ahead, commit that and push it, and then let's run it locally. So make change ptrace Yama requires sudo, and then now let's try to exec again. So you can see without having to stop the container restart it, recopy all of our stuff, and go through that whole dance. We've been able to kind of get around that limitation and run the debugger. So one thing that you'll notice that you would have noticed when we ran the debugger on the host is that when we hit the breakpoints and all of that stuff, when we kind of searched around what was going on, we could see the source code. So let's try to do something like that now. So let's set a breakpoint at hello server again. And we can see that Delve was able to find it, set a breakpoint there at this function address for this function. And here's where this is defined in our source code. So we continue execution, make another curl request, and we can see that we've hit the breakpoint, but we don't have any of our source code. And this is again because we're running the debugger in an environment that's outside of our host, right? So within the containers file system, we don't have our source code. We don't have any of that stuff. We don't even really have go root. So we don't have any of the code that we need to look at to make, you know, using a source level debugger worthwhile. So let's take a look at how to fix that. So we'll leave our container running. And now what we want to do is we want to fix a source code issue. So we're going to need to get the source code into the container and also do some tricks with Delve to make it kind of know where we've put the source code, because it's not going to be where we expect it because of how the application was built and because we're copying stuff to different locations. First thing that we're going to want to do is introduce a slightly new concept. So let's create a new directory, not under build. Let's create it globally, and we're going to call it hack. And so one of the convenience features that Delve has is the ability to kind of run with these like initializer files. So essentially, it allows you to kind of run Delve with and specify a file in such a way that whatever commands are in that file will be treated as Delve commands that are executed when the debugger starts. So let's put our little init file into our hack directory and take a look at it. So these are Delve commands. So we can do this configuration kind of at a global level, but if you just need like substitution path or configuration at a local level, or if you have a bunch of commands that you always execute at the startup of a debug session, this is a good way to kind of be able to version them and have them in a place where you're not retyping them out constantly. Especially if this is like right at the beginning of your debug session, it can be kind of like a headache to have to retype something just to get back to a useful place, right? So here we're defining a substitution path rule. So we're saying anytime you see this path in the source code in the binary, replace it with this path. And similar for here, right? So you remember when we had our little builder container image, we built in project. So the source code during compilation, that was the path that was built into the binary for all the debug information. And so we want to replace that with source. And I'll show you why both of these two are important right now. So let's figure out how to kind of do this exec again, but be able to see the source code from the host so that we can have like a good source level debugging experience. So I'm going to add in a new make command, and then we'll take a look at it after I've added it. So now we have this new command, and it's kind of a mouthful, right? Exec delve basic container with source. And it does a lot of things. So pretty much all of these commands just had a single statement. And now this one's a little bit more involved. So let's take a look at what's actually happening here. So the first thing that we're doing is is copying the current working directory to a location within the container at source, right? So when we go back and look at the init file, we see we want to replace project and replace that with source. And that's why, because that's where we're going to copy the source code into the containers file system. Similarly, we're going to take our go root and copy that into the container at /go root. And then we're also going to copy in this init file that we have out here. And we're going to put that, technically that should already be in here under a source hack init file, but this just kind of makes the path a little bit easier. So we'll recopy that in and put it at the root. And again, that's just our little init file that handles our config path substitutions. And then we're going to re-exec into the container just as we've done before. But this time, we're going to specify to Delve this init flag and the path of the file where we want to, where the init file lives. So let's add this. Sync that up. And let's run that command and see what happens this time. So make exec basic container with source. So we're doing all of our copies. So all of the Docker copy commands seem to have worked. And now we're back within a Delve prompt, right? So we've reattached with our init file, and we should be able to kind of see some of the source code. So now if we start listing stuff out, so list is a command which if you're unfamiliar with it, prints the source listings of where you are right now in terms of like the thread and go routine context. So you can see that we actually have some assembly code here. So we're actually getting code from go root. You can see right here where the path is. We have code. So let's set a breakpoint again at our hello server function, continue there and make sure that we have the source code there as well. Okay, so we set our breakpoint once again, continue execution, and the only way we can hit this breakpoint is if we trigger it. So let's trigger it with a curl. And just like that, you can see that we have our source code available. We're kind of back to parity with what we were on the host. So now you're ready to have a productive debugging experience within a container. And you have source code listing and all of that stuff. Okay, so now what we want to do is I want to kind of show a different approach, right? So one of the things that you can do, like let's cut out some of these steps. What if we had a container that was kind of built from the ground up to kind of be more readily set up for debugging. So let's go ahead and see what that looks like. So to do that, we're going to we're going to create a new Docker file. So this Docker file looks very similar to the one from before, but there's a few different changes here. So we're installing Delve within the container itself. We're copying Delve from the builder container. And then instead of running our app as the like entry point into the command, we're actually running Delve. And so we're running Delve in kind of an interesting way. So we're running Delve and we're running it in the way that I showed earlier, where you can exec pre-built binary. So we're using delve exec and then passing this continue flag, which says basically as soon as the debugger attaches to the program, just go ahead and continue it. Don't sit there waiting for input. we're running it in headless mode, which means that it's basically just the server. And then we're giving it the server someplace to listen to and telling it which like what to run, what binary to exec. So that's our new Docker file. Let's create a command. Let's get our command over to build that image. And first, let's copy over a couple commands. So the first thing that we'll want to do is actually stop the container that we were running before. So we have a little make file, a little make command to make that easier. So let's say make stop basic container. Okay. And then we want to build our new container. So let's just add all this stuff up. And let's start running some commands. So let's build our new image. So build image with delve. That's going to go through and do its thing. Okay, so we built our image. So now let's run it. Let's go through here, grab this. So we have this new command that is run delve container. So you can see we're running the delve image. We're exposing a new port. So we're exposing not only like our web server's port, but also the port for the debugger. And this is going to be important a little bit later. So we have our new image. We're about to run it. Let's actually add that. Add. Okay, so let's run the container. So similar to what happened before, we've run our container and the server should be running. And this time it should be running under delve, but it should be running. We should be able to get output from it. So let's curl, and you can see, I think I might have recopied this. So let's just get that out of there. Yeah, you can see we get output. Our server is actually running, and we have delve running as well, but delve is already running within the container. We're outside of the container. So how do we interact with it? So let's take a look at what that looks like. Essentially, what we're going to want to do is delve by default is built with a client server architecture. So it's already kind of built to be able to run remotely. It kind of runs remotely locally. So being able to run connect to another remote instance is pretty much par for the course for the debugger. So let's see how to do that. So it's literally just as simple as DLV connect and the where you want to connect to. So we have delve running. We have delve running remotely within a container. We want to connect to it. So let's execute that command. Boom. And then there we can see, let me go ahead and add this all. We have run delve within the container, run it headless, and we've connected to it from outside the container. And actually running in this way offers us a little bit of benefit, right? Just kind of right out of the gate. Because you see we just connected, and if we run that list again, you see without even having to do anything, right? We didn't copy any source code. We didn't do any of that stuff. In fact, we stopped the container, restarted it. So nothing has been copied in to that container. There's no source code or anything like that. But you'll notice it's still not exactly perfect. So let's set another breakpoint on hello server and continue. And let's hit that again. You can see we still don't have the source for our actual source code, the source code that we really, really care about, the code that we're writing. So how do we fix that? We don't have to do any kind of copying or anything like that. We can actually just take advantage of the init file that we already have, or actually a slightly different init file. So we have the delve container init file. Now let's create a new one. So we have the delve remote init file. So it's essentially the same thing, except for the substitution path is going to be just for project, because since we're running on the host, our go root is going to be the same. And you might notice, like, if you're following along and executing these commands, you're going to want to change this directory to wherever you clone the repo into, and that goes the same for actually, yeah. So it's only for this. So since we're running the debugger on the host and not within the container, Delve is going to be looking for the source code on your host file system. So change this to wherever you've cloned this repo. So now we have this different init file, and we're saying from the host, Delve with that init file, connect back to the remote server. So let's see what this looks like. So again, we're back at a prompt. If we set a breakpoint, breakpoint already exists. So if we continue execution and hit this, now we see that we actually have source code available, right? So it's just as simple as like setting up your environment and setting it up consistently and reliably so that the debugger can find everything that it needs, which in this instance is going to be the source code, but there could be other configurations that you might want to tweak, or just in general, having an init file and having that versioned in with your repo can be really helpful for debugging if you find yourself doing the same kind of series of tasks when you start up a debug session. Okay, so let's commit this. Okay. And let's copy another command to stop our delve container, since we're not going to need that running anymore. Okay. So now all of our containers should not be running anymore. Perfect. So that essentially wraps up the portion for containers, just, raw containers. So now let's take a look at what this experience looks like extrapolated out to kind of running on a cluster. So a lot of the concepts are going to be the same, but we'll see a few kind of different things in the end. So let's copy over a few commands that will be instantly pretty useful. So again, adding in just a nice little divider here, a few variables just to kind of keep things nice and clean. And then here I've put in a few kind of nice to have commands. So let me get those up before I. Okay, so now those are up, and I'll kind of talk through them a little bit. So these are all mostly helper commands for anybody who doesn't already have these tools installed in the system. So we have a make command for installing kind. So kind is what we're going to use to set up just kind of a small little local Kubernetes cluster to test on. And then if you're running on OS X, here's how to install kubectl, and then a different way for Linux. There's other ways to install it. You don't have to install it through Snap or Brew or whatever. But if you want a quick way that should work for getting these dependencies on your system, this should do it for you. Now, the first thing that we're going to want to do is create our cluster. So this is just happening very easily with kind. We just create our cluster and give it a name. We're going to call it buggy cluster. So let's do this. And let's create our cluster. So kind does this pretty quickly. You can see we're starting up the control plane and everything like that right now. And while we're waiting for this to happen, let's go over some other stuff. So we're going to want to start deploying some services onto our cluster. So let's prepare for that a little bit. Let's create a new directory called deploy. And we want to we want to get some stuff running on our cluster. So let's get a YAML definition of just a basic service, and we'll take a look at it real quick. So we have a service definition, a Kubernetes service definition, and then we have a deployment. And that deployment has two replicas. It's all pretty simple and basic. So now that we have this spec, we want to get it on the cluster. So let's create a little command to deploy our service and deploy it real quick. So we'll do make deploy service. And now if we take a look at it, we can see we have pods running for our basic deployment. They're ready and they're running. So now we have a cluster running. We have an application running within that cluster. Again, now how do we debug it? So this is a cluster created through kind. So the cluster is local and just running on containers, but you can extrapolate, like this would be a lot harder if it was a real cluster on like Google Container Engine or something like that, where we're actually dealing with like different nodes, different hosts, and that kind of thing. So we kind of have to go through the same flows we did just with the basic container. So we have our debugger, we have it locally here on the host. We've already used it. We've already seen that it's there. But how do we get into the context of our Kubernetes cluster? How do we get into the pods? So similar to the flow that we went through before, we're going to want to copy the debugger into our pod. So kubectl has a nice helpful command for that. Just kubectl cp, again, the path to delve, the pod that we want to copy it into, and then where we want to copy it to. Sync that up and let's run it. So make copy delve to pod. Okay, so we've executed that command, and now our debugger should be in the pod context. So now what do we do? So now that we've copied our debugger into the pod, we're going to want to, similarly as we did just with the basic container, we need to execute into that context so that we can start using the debugger that we copied into it. So let's get a new helpful new command to be able to exec in. And then again, we're just using some helpful kubectl stuff. So kubectl exec, the pod, and then what we want to execute. And you can remember we built our container images with Ubuntu, so they're going to have bash. If you typically what you use multi-stage like builder containers and things like that for is to end up with a scratch container. So that can be difficult in terms of like copying new binaries and things like that into that Scratch container namespace, because you might not have everything that you need to execute some of these other processes, like shared objects or anything like that, if you have a binary that's dynamically linked. So I'll go over a solution for that later if you have like Scratch containers that you're running within the cluster, so that you just have the binary itself. But for this instance, we do have access to a shell. So let's exec and get a shell prompt. So let's run make exec into pod. Okay, so now we're in the pod. We have a shell. So let's try to use delve to attach, right? So how you would actually do that was similar to how it was shown before in an automated fashion. Just delve attach and then the PID that we want to attach to. So again, we see this this issue that we kind of ran into with the ptrace YAML scope. So this is again like something where you might not want to like set this globally on another server or something like that. So how can we get around this issue when we have this container running in a cluster? It might be on a node that we might not even be able to have access to. So let's get out of our little exec and see how we can fix that. So here, let's add in another little service YAML definition, and I'll expand this a little bit. So here we don't have the service definition. We just have the deployment definition, and I'm kind of putting it out into its own file, even though this is for the most part a clone of the deployment definition. It's just easier to kind of see it in a different file. But one thing that you'll note that we've added is this security context here at the bottom. So similar to what we had to do when running the Docker container with doing the cap add sys ptrace, it's a similar concept here, but we just define it and express it a little bit differently. So we have this security context with capability, and we want to add sys ptrace. So now that we have this new service file, we want to redeploy our deployment to recreate those pods so that we can re-exec into them and be able to actually start debugging our process. So let's grab this command here, redeploy service. Does kind of what you would think it would do. It does a kubectl apply to the new YAML file that we created, and that's essentially going to cause like a rolling deploy. So let's get that kicked off. And it looks like we have some warnings and stuff like that, but it's kind of not really. It's just saying, you know, we're gonna take care of stuff for you. So it should have re-rolled out. We can see the old deployment still terminating, our new one standing up. So let me go ahead and add this. And now let's do the exec again. All right, so we're gonna have to first kind of go through the dance of copying and then re-execing. So since we've done the rolling deployments, the pods and the containers have all been killed and restarted. So we kind of need to go through that dance again. So first, let's copy delve into the pod, and then we'll go back and we'll exec into the pod and try again. And there you go. You can see we've kind of overcome our issue, and we're able to attach to our process and started debugging. We can get to the debugging prompt and we can kind of do what we need to do. Now, you'll notice again that we don't really have source, right? So I won't go through this all again just for the sake of time, but essentially what we did before with copying the source and doing the config commands and stuff like that, we'll also have to do in this situation as well. Okay, and let's get out of this exec. Now let's keep moving forward. Let's look at what it would look like to do what we did before with the container, but in the cluster, and do remote connections. So we're going to want a new service definition here in our deploy area. So this is kind of basically the same as the other service base, the basic service that we defined. This one already has sysp trace capability. We're exposing some more ports. Again, we're exposing 9090. That's the port that our remote Delve instance is going to listen on. And then here we're deploying a new container. So it's a container that we've already created that already has Delve and the tools that we would want in it. And just like with the container that we saw before, this container image by default, it's going to start the application that it's running under a headless Delve server. So Delve will already be running, it'll already be initialized. Once we put this in the cluster, we just have to connect to it. Now, that might not seem so like exciting or anything like that, but it's actually a really, really powerful concept and something that I've used in like staging clusters, and I've seen it used before. You wouldn't want to do this in production, obviously, because you're kind of opening up yourself to a world of potential pain. But if you have like a dev cluster or a staging cluster or something like that, where you tend to need to drop into it a lot to debug, it's a good idea to kind of go back to what we did with this and just start your application running under a headless version of Delve that's auto-continued, so that at any point you can just kind of connect to that headless instance and start a debug session. You don't have to like worry about copying anything around or whatever. And if you already have this kind of like debug tool container, you can already like build it with the source code and everything that you need in it, so that you don't have to do any copying at all. So we've already redeployed our service. Now let's take a look at what it looks like to actually like connect. So let's see. So okay. So what we actually want to do is deploy our new service. So we have the service definition, and now we actually want to deploy it onto the cluster. So let's run make deploy Delve service. So we've created our new deployment, and we should be able to see it starting to pop up there, right? So let's get this committed and pushed up. Okay, so we have our service running into the cluster. Now, how do we connect to it? So one of the things to note is that the Delve remote connection doesn't have any kind of like encryption, TLS, any of that kind of thing. So when you actually want to do a remote debug session, it's kind of typical to do it through like an SSH tunnel or something like that, so that you get that kind of security through the connection, so that nobody can kind of spy on you, right? And luckily, we can achieve that in a similar way with Kubernetes. So what we're going to do to be able to connect our local Delve to the remote Delve instance is we're going to do some port forwarding. So we want to port forward 9090 on the Delve pod to 9090 locally. And then what that will do is allow us to connect with Delve locally and start a remote debug session. So let's start that up. Let's see. Okay, So we started our port forward, and this command just kind of sits there and kind of waits while the forwarding is actually happening. Let's see. Now we can actually reuse one of the commands that we used earlier. So since we're port forwarding and we have this port forwarded to our local system, we can just kind of reuse this connect, right? Just like we were doing before. So make connect to remote delve. So now you can see we have delve running in a container, in a cluster, potentially on another node. And then we have the delve like CLI, the front end running on our host, and we have it connected. So we can list, and you can see again, since we're running delve on the host, we still have like access to like what the typical go route would be and those kind of things. Again, you probably will have to do some source path substitution for your local files, but it's a lot easier when you're able to run like the delve client locally and the server remotely, because like you don't have to copy source files anywhere or do any of that stuff. The source files should all be there locally, hopefully. And then all you have to do is kind of issue some config commands. And like I said, you can configure delve globally. It has a global config. So it could be easier for your kind of workflow to do it that way. So let's get out of this, and we don't want to kill the instance, and let's kill the port forward. Okay, so now what we want to do, so the final way that I want to show how to debug within a cluster kind of takes advantage of a different kubectl command that is kind of made specifically for this. So kubectl has a subcommand called debug, and it can work in a few different ways. So you can do debugging with ephemeral containers, which means that once like that kubectl debug session is ended, that container will kind of go away and won't remain on your cluster. This is a pretty new feature and requires special configuration in your cluster. So like if you're doing like Google cluster or AWS cluster or something like that, where the control plane is managed for you, you don't really have a lot of control over it. You might not be able to take advantage of it, but you can still use kubectl debug without the ephemeral container aspect. So let's look at what that looks like. So let's copy over a new command here. So we have a new makefile command, kubedebug. As I mentioned, just kubectl debug. We specify the pod that we want to debug, and then this is where it gets kind of interesting. So we specify an image that we basically want to use this command will create a new container within the pod that we're targeting. And we're passing along a flag to say share processes. So this is saying we want the new container that we're adding into this pod to be able to see join the process namespace of the other containers in the pod. That way we can attach our debugger to another process in a different container. Otherwise, the namespace isolation that we talked about earlier would prevent that. And then finally, because we're not using an ephemeral pod, we're copying the pod that we want to debug into basically we're creating a new pod, calling it debug pod. That's gonna contain the containers that were in the original pod plus the pod that we're injecting, so our delve service pod. And then we're just specifying a command to execute. So we're basically just executing bin sh, right? So let's add this in, and let's say let's run it and see what it looks like. So make kube debug. So we get the output. We say defaulting debug container name to blah, 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 blah. If you don't see a command prompt, try pressing enter. Let's press enter, and we see our prompt, right? So the Delve service container was one that we saw the definition for earlier, and we know that Delve is going to be here. So we already have Delve running locally. If we want to see the different processes, we can see the app process is running here, and we can see it as PID7. So to attach to it, all you need to do is, okay, so we get hit with some of the YAML ptrace scope again. It's probably like a missing configuration again to add like sys ptrace or something like that. But you get the gist of it, right? So the beauty of this last command, and I wanted to save this to last because it kind of wraps up a few things where you can imagine, along with the other container images that you're building during your day-to-day workflow, maintaining like a debugging tools container image. And that container image can contain, your debugger, profiler, other tools like strace or whatever else you need, perf, whatever. It can contain all those tools, and it can contain the source code for like a particular release or version or whatever, so that you don't need to copy anything over. All of that stuff is already contained in that container image. So when you do this kubectl debug, and when you attach this new container image to an existing pod, it's already going to have everything there that you need. So I think that's a really, really cool and powerful way to kind of maintain, like I said, kind of like a debugging tools or developer tool kind of container image that you just have with you. And ideally you build it like simultaneously with, the other images that you build, so that it has the right source code and all of that stuff to line up for the particular like version of the process that you're trying to debug or whatever. But it just prevents you from having to do a lot of manual work, and just kind of wraps everything up into a nice little package that you can just deploy and then easily remove. So again, as I mentioned, we haven't set up our cluster to use ephemeral containers, so it is going to create a new container for us. So we can clean it up with this. So if you don't want to tear down your whole cluster, just make clean up debug pod. It'll delete our debug pod. And then finally, eventually, once this finishes, we're going to want to just go ahead and delete our cluster because we're done. So let's add cleanup, and while we're waiting, and sometimes this command takes like a super long time to run, but essentially we're at the climax. So the next step is just to delete the cluster for our own kind of make sure we're not kind of leaving anything around, and essentially that's it. That's kind of a bunch of different ways to debug, get your debugger where you need it to be, and get your environment set up so that you can have a lot of success. So yeah, I hope everybody was able to follow along. I hope the format was good, and yeah, if there's any I don't know how much extra time we have, but if there's any questions or anything, I'd be happy to go over them.
Yeah, we do have time, so if anyone's got questions, feel free to chime in. I do have one. I'll take the mic for this one. So actually, two things. On your second to last command on the delete, if you do a -- force, that'll ignore the grace periods on the pod, so it'll kill quicker.
That's a good addition.
I use that all the time. I have no patience. So just a little quick background on myself. I'm a Kubernetes admin. So I've got a utility I wrote that runs both as a plugin and runs in the cluster. And it runs as a cron job every day, right? So unlike your example where you've got basically an HTTP server that starts up and runs constantly, and you in your image command, you did the -- continue. If I continue, I'm just going to run through, and the process is going to end, and the pod will be completed. Is there a way I can build that image with a breakpoint set so that when it starts the job and creates that pod initially, it stops immediately, and then I can step through it?
Yeah, absolutely. So, so for that, what I would do is kind of take advantage of another thing that I showed, which was the init files. So the init file, you can put in there any valid delve command, and it's gonna execute that on startup. So what you would do is you would put your breakpoint command in there, and then when delve starts up, it'll set that breakpoint, and then if you add the auto continue, it'll run it just up to that breakpoint, and then you can connect to it later and then do what you need to do.
Okay, awesome, perfect. Yeah, this is debugging this thing because I'll see different behavior from the command line to the cluster version, and it's actually batty.
Right.
So I'm constantly recompiling, rebuilding, and running it again to check it. So this is awesome. This has been very helpful.
Yeah, and that's one of my kind of like favorite tricks for cluster debugging. The first is like for staging your test clusters, I really just love like starting long running apps just under the debugger, because then you don't have to really do anything special to start a debug session. It's just connect to it, and it's already there. And with the like the kubectl debug command is really cool as well, but that copies to another pod and like introduces some other stuff where you're kind of in a slightly different context. So the ability to just have the debugger already there, just running, and you can connect to it, I think is really powerful.
Now, you mentioned running in production. Do you run that until like production and then have a separate image that kills the debugger? Or
so what I would do for production images is I would just have them as like just basic scratch images or whatever you would normally run in production that wouldn't have delve in the image at all.
Right. Yeah.
Because even if you even if you were to run with delve but never connect a debugger and maybe never even expose the port, like make it hard or impossible for anybody outside to even hit that delve instance. Even though we're not actively doing any kind of debugging, you could notice like actual performance regressions, because what actually happens underneath the hood is like anytime there's a signal that's sent to the process that we're debugging or anything happens, there is a context switch back to delve to then have to recontinue that process. And those context switches actually happen a lot with Go, because I don't know if you're familiar, but recently they introduced the method to be able to kind of interrupt a Go routine so that you can run another Go routine. But basically, like if you have a Go routine in a tight loop and it's never yielding, that Go routine can starve a thread. So that async preemption, that's what it's called. So that's done with by sending signals. The runtime sends signals to itself basically to interrupt a thread so that the Go routine can pause and another Go routine can run. All that to say, there's tons of signals usually being sent to and from a Go process. So if you're running it under a debugger, you can see like some performance regressions there.
Gotcha. I appreciate your time. This was very enlightening. Thank you for sharing it with us.
Absolutely.
Well, I'm a little late here, just like I was late getting into the to the meetup. But is there? You covered that before I got into the meetup. Your GitHub repositories for this, so that I can go.
I'll post that to the meetup. So it's in the chat, but I'll post it in the meetup.
Okay. Yeah, I didn't see anything in the chat, but it was probably because it was before I actually could join.
Yeah, I'll get that posted out there for you.
That's cool.
Yeah, so I'll keep that open. So basically, it's like a main repo, and I just created a branch for this meetup. So that command should clone it, put you on the right branch, and then the whole repo will already be filled out. But you can like kind of go through the Git history if you want to see it kind of play by play, like what things are related to each other. But then like you can kind of browse through the makefile, and that's why I kind of did it that way, so that like since this is somewhat interactive, if you want to go back and be like, oh well, like what was that command again or whatever, it's all just stored there and kind of self-documented it in a way.
All right, great.
And
I do appreciate that.
I just posted it again, Brian. So
Okay, thank you.
run that with your git clone. So Derek, thanks again for your time. Thanks everyone for joining. Hope everyone has a great St. Patrick's Day tomorrow, and we'll talk to you next time.
Thank you.
Thank you.